All right, excuse me. We're going to look at some problems from section 9.7, where we're using our trig identities, the fundamental trig identities given to you in class. And here's the sheet that we gave you. And I would certainly have these out. You're going to be able to use these on a quiz or exam, this sheet. So you don't have to memorize them, but the more you use them, obviously, the more you'll remember them. And we're going to use these to simplify and or verify a trig identity. Okay, so here I have sine x plus cotangent cosine. So first thing I think of is when I look at cotangent, I'm going to change that to be cosine over sine. So that gives me a cosine squared over sine. So I have a sum. So the only way I'm going to be able to add these two is if I have a common denominator. So I'm going to multiply the first term by sine x over sine x. I'm multiplying by 1. So notice I have a sine squared x plus a cosine squared x over sine x, right? Because we have the common denominator. Well, that's one of our Pythagorean identities. So that equals 1 over sine x, which we know is cosecant x. So there we are in its most simplified form. Okay, our next one, 1 over tangent squared x plus 1. So anytime we have a tangent, we want to change that to sine over cosine. So that would be sine squared x over cosine squared x plus 1. Now again, in order for me to be able to add these two, I have to have a common denominator. So I'm going to change our 1 to be cosine squared x over cosine squared x. So now, again, notice we have sine squared x plus cosine squared x over cosine squared x. And we know, again, that's 1. So we have 1 over 1 times cosine squared x. Dividing fractions, we take the reciprocal, their denominator, and multiply. And so that would equal cosine squared x. All right. So let's look at a couple of identities. So again, our goal is to have the left and the right side equal each other, and we generally want to choose the more complicated side and simplify it. So that in this case would be the left side. So we want it to equal cosecant. So a couple of things. I'm going to change cotangent again to be cosine x over sine x. And so I look over here and I'm trying to figure out what am I going to do to simplify that? Well, I have a sine x here, and I see that I have a 1 plus cosine. So what resonates with me is if I multiply this by 1 minus cosine over 1 minus cosine, I'm going to end up with, in a long run, sine squared x. And the reason is because, let's see here, right? We end up with 1 minus cosine squared x. And we know that that is equal to sine squared x, right? That's one of our Pythagorean identities again. So if that's going to be sine squared, this has to be sine squared in order to be able to add the two equations. So I'm going to multiply that by sine x. So here in my numerator, I'm going to distribute. So I have sine x minus sine x cosine x, right? That we've already said is sine squared x. That's a sine squared x. And then here I have plus cosine x sine x. Well, we have a negative and a positive. That adds up to 0. Now I have a sine x over sine squared, which is the same as 1 over sine x, which equals cosecant x. And so we're done. So again, a lot of this is looking at what our terms are, what can we change them into, and having this in front of us, it certainly helps. In our Pythagorean identities, we do end up using a lot. Here we've used the tangent, cotangent ones, as well as reciprocals. You don't see these as much, although certainly occasionally. Okay, last one. So I have this sum and I have this quotient. not as easy to figure out which one to simplify. Because, you know, sum, if this was a product, I would definitely say I would go with the sum and simplify that. And you probably still could. But I'm going to go with the right side here, and I'm going to multiply this similar to what I did before. 1 plus sine x over 1 plus sine x. And I'm going to end up with cosine x plus, I'm distributing, cosine x sine x. Actually, you know what, I'm seeing now that that's a mistake. I'm not going to distribute. You'll see why here in a second. And if you did, you would factor it out again. So this is 1 minus sine squared x, which we know is cosine squared x. So here's, look at why I didn't distribute. Because here I'm seeing I have a cosine divided by a cosine squared. And so now these are factors because I didn't distribute. So that simplifies to cosine x. So now I'm going to split it to 1 over cosine x plus sine x over cosine x. Again, because I see what I have on the left side and I know what that has to equal. There's our reciprocal. And here sine x over cosine is tangent. So there we are. All right, let's redo that last one. What if we looked and tried to change the right side? So we end up with that equals cosine x minus, not plus. All right, so what would I have done if I looked at the left side first? So secant I would have changed to 1 over cosine x. And tangent I would have changed to sine x over cosine x. So now I have a common denominator, so I can write 1 plus sine x over cosine x. And so I want to get to cosine x and 1 minus in the denominator of sine. So that I need the 1 minus sine x. So now again, here I am in the numerator. That's going to be 1 minus sine squared x, which we know is cosine squared. So I'd have cosine squared x over cosine x times 1 minus sine x. That simplifies to cosine x over 1 minus sine x, which is what we have on the right side. So either way, we would have gotten there. All right, I hope that helps seeing some simplifying and verifying of identities, and we'll see you soon.